This is the tutorial video for the final project for Mechatronics 241, and we're looking at the project folder on Learn. There are two files, the project specification and also a zip file that contains the Microvision 5 starter project, and it's been configured with specific memory allocations and stuff that you're going to need for this project, so you definitely want to use that when you start the project. Don't create your own. And so let's look at the project specification. From the first sentence, you can see that the project involves solving the Byzantine generals problem, or rather you're implementing the oral message algorithm that was covered in the fault tolerance lectures pages 11 to 13. Page 13 is especially important. You're going to be implementing the part that distributes the messages. You will not be doing the part that calculates the majority values. So you're doing kind of half the algorithm, I guess. And I'll come back to the test thread that we see at the bottom here. But first I actually want to talk about the test cases. And so there are 4 test cases that are given to test your code, and there will be 4 similar test cases with minor tweaks to them for the marking. And so let's look at case 0, for example. It says that there are 3 generals, and there's going to be a Boolean array that indicates for each general whether it's loyal or disloyal. So true is loyal, false is disloyal. So general 0 and 1 are loyal, general 2 is disloyal. And if you remember the Byzantine generals problem discussion, it can only solve it if the number of generals is greater than 3 times the number of disloyal generals, and that is not the case here. The number of generals is equal to 3 times the number of disloyal generals. So for test case 0, what's going to happen is some setup code that you're going to be writing will count the number of disloyal generals, it'll count the number of generals, and it will say we can't do it. So you'll see that the expected output is on the next page, and you can see that there is an assertion that n greater than 3 times n failed. And then just return false, and that's all you got to do for that case. So there's 3 more cases, and for cases 1 and 2 there are 4 generals, and for case 3 there are 7 generals. And for cases 1 and 2, general 0 is loyal, general 1 is disloyal, and generals 2 and 3 are loyal. Now what comes after that are the commander. So which general is sending a command? What command are they sending? So for test case 1, it's sending retreat, and there's going to be 1 general that's picked as the reporter general, and so the final level of the OM algorithm, you receive a message and you just use it as received, and it's just going to, in this case general 2 is going to print out the messages that it receives in the lowest level of recursion. So, and then there's cases 2 and 3 there, and you can see for case 3 there's 7 generals, and there are 2 disloyal generals. So general 1 and general 4 are disloyal in that case. So you can see for case 2 that the commander is not general 0, it's commander 1. So the idea is that the test cases should increase in complexity and make you add stuff to your code. Each test case will be worth 25%. And like I said, the marking test case will be very similar, just tweaked a little bit so that people can't just hard code the output. Okay, so let's diagram what's going on for test case 1. So this is the final project. And so we have an example where we have general 0. Let's do them in this pattern so that their messages can get to each other nicely. And in this case, general 0 was the commander, so let's just annotate them. So they were the commander. So I should write the parameters down here. So n was 4. The loyalty array had the values true, false, true, true, and the commander was general 0. The command was to retreat, and the reporter was general 2. So it's going to output what it gets. Okay. So general 0 is the commander. General 1 is the traitor or disloyal. And so general 0 is going to send the initial command to its 3 lieutenant generals. And that command is retreat, and it's going to, every time they send a command or pass a command on, they preface it with their ID number. So it sends 0R to each of its lieutenants. So each of the lieutenants will receive that message, and then they will send that on to the other lieutenants. Since in this case m is equal to 1, so let's so we know here that m is 1. That's the number of disloyal generals, because you're told who's loyal, who's not. Okay, so General 1 is the traitor. They're going to send a message to General 2 and General 3, and since they're a traitor, they're actually going to change the message. So they're going to send attack. They're going to say that that came from General 0, and then they'll preface their ID on it as well. So there they are, being unreliable. Now General 2 is loyal, so it's going to faithfully tell the other 2 lieutenants what it heard, which is, so it's going to preface its message with its ID, and it's 2, and it heard from General 0 to retreat. And General 3 will do likewise. So General 3 will communicate with Generals 1 and 2, and the message there will be 3, 0, retreat, 3, 0, retreat. So every time they forward a message, they're forwarding, they're prepending their ID number onto it. And an important thing to note is that for 3 to know who to send their message to, they can just look at the message. So if we look at the message here, we got 3 and 0 in there. So it doesn't need to send it to General 0 or to General 3. It just needs to send it to General 1 or 2. And that's something that will be useful when you're doing the implementation. Okay, and General 2 is supposed to output what it receives at the lowest level of recursion. And so General 2's output will be 1, 0, A, received from General 1, and 3, 0, R, received from General 3. The order of the output doesn't matter, meaning that we could have put the 3, 0, R before the 1, 0, A. Now, it would not be okay to scramble the message. So for example, 0, 1, A would not be acceptable, or 0, 3, R, or something like that. So let's go back to the spec and see if we got that right. So the expected output for test case 1 was 1, 0, A and 3, 0, R. So now let's look at how the code's going to work. So I'm going to go back up to page 1 of the spec, and there's a file that's included in the project called final.c, and what it does is runs one test thread, and that test thread runs this function, test cases. Test cases iterates through however many test cases, 4, and for each test case it calls a number of functions. So, well, first it prints out the test case number, then it calls setup, which you're going to write, and that's going to record information and do things like create any message queues or semaphores that you might need in your solution, that your generals will need. The next thing that it does is it's going to start the generals, and it just passes it the number of generals n, so 4 in case 1. And so it's going to start 4 threads. All threads will know their ID number, 0, 1, 2, or 3, for case 1 at least, and case 2. And they will be running the general function which you're going to implement. Once those generals are started, they're going to be waiting for the command from the commander. And so broadcast is going to be executed by the test thread, and it's going to impersonate the commander. So General 0 will not actually participate in this round or in this test. So your broadcast function is going to send the message, which will be for test case 1, 0:R, to generals 1, 2, and 3. So they're going to have message queues waiting to receive those messages, and then they'll do something with it. I have said, the message is 0:R or something like that. So that kind of, I solved this using a string, as did some other people. I've seen other people use structs. I think the string is maybe a cleaner solution, but you can decide what works best for you. So it calls broadcast, and your broadcast function will send the message, and then it's going to wait. It's going to synchronize with the general thread. So it's going to wait for the general threads to probably signal their semaphores to tell it that they've finished. So it'll know that the output has been printed to UART1 by the reporter, and then it will run the cleanup code, which will just delete any message queues or semaphores or whatever has been allocated that you want to reclaim. And then the generals will be stopped. So the 4 general threads for test case 1, 7 general threads for test case 3 will be terminated, and then we'll move on to the next test case. So I'm going to diagram what's going on here, and then I'm going to fill in some pseudocode for each of the 4 functions that you have to provide: setup, broadcast, general, which isn't seen here, but it's run by start generals, and cleanup. Let's go back here. So what we're going to have is, I'm going to squeeze this on the left side a little bit. So you've got your main that starts running, and if you look at the code that's provided, the main's very basic. All it does is initializes the kernel, creates one thread, which is the test thread, which runs the test cases function, and then it starts the kernel. So that's all main does. So main basically spawns our test thread, which runs the test cases function. So I'll just annotate that. So this is running test cases, and so what does that do? It will first call setup. I'm just going to show for one test case. It'll actually iterate through this. So it'll call setup, and let's just, the parameters that setup gets are n, which is the number of generals. So that would be 4 for test case 1, so I'll put that in green. And it is passed a Boolean array that indicates the loyalty of each general by position in the array. So for test case 1, it's going to be true, false, true, true. And the only other piece of information that it needs is the number of the reporter. And that was general 2 for test. Oh, I wanted to do that in green. So that was 2, and these values are particular to test case 1. Okay, so in setup, I'll write the pseudocode after, but you're going to record this information because your general threads are going to, or your general function is going to need this information, and you're going to be allocating some some other message queues and whatever you need. So once it calls setup, then it's going to call start generals, And start generals is going to create 4 general threads, and they will each have an ID. The code that figures out their ID is provided. Not that you couldn't do it. Okay, so we got 4 threads there, and they're just going to be waiting for a message to come in from the commander. So each general is going to need a message queue, and you're going to have to figure out how big you want to make that. And there's hints about how big it has to be if you look at fault tolerance lecture page 13, where I actually count or calculate the number of messages sent. So those generals are now sitting there, they're kind of idling, waiting for the broadcast. So the next thing that the test thread does is it calls broadcast, and it tells it that the command is equal to, in the case of test case 1, it's retreat, and the commander was, in that example, it was general 0. It won't always be general 0. In test case 2, it's general 1. And so broadcast job is to send a message to each of the generals. Now, it's actually impersonating general 0. General 0 in this scenario, or in this test case, is actually the commander. So I'm going to erase, I didn't mean to draw this one here. No message is sent to general 0. It's going to do nothing for test case 1. It sent the command, which was actually done by the test thread for test case 1. Okay, so that command gets sent, and in our example it was 0:R. So that's what's going to be in each of those message queues, waiting for the generals to implement the OM algorithm with. Now, the generals are going to need to implement the OM algorithm. General 2 is the reporter, so it's going to output what it receives in the lowest level of recursion, and then they need to tell broadcast that they're done. So broadcast is somehow going to be, this is going to get kind of ugly here, but it's going to be waiting on each of those to tell it that they're done. So you're going to use a semaphore probably, although you could use other ways to do that. Okay, and after broadcast happens and the generals run and they exchange messages and they tell the broadcast function that they're done, broadcast returns, and so then the cleanup function runs. So if there's anything you've allocated that you're not going to use for the next test case, you would clean it up here, and then the stop generals function is called, and it's going to stop all 4 generals. It's going to terminate them, and then a new test case will run. So this happens 4 times for 4 test cases. So let's look at what should be in the pseudocode for each of those. So let's look at the setup function first. So it needs to record some information. So it needs to record n, the number of generals. It needs to record that loyal array, who's loyal, who's not. You're probably going to want to calculate the number of disloyal generals, which is m in the notes, and you will also need to record who is the reporter. So the general threads will know who's what and who should be reporting, printing stuff out. And you will also need to create message queues, and I'm going to assume that you're going to use semaphores. So semaphores and whatever else you decide that you want. Now, one thing I should note, there is a requirement for this project that any communication between the generals is done via the message queues, and that you're not just writing to like a shared array in memory. So we will be checking that you're actually using the message queues, because that most closely simulates or approximates what happens in a real distributed system where they're not sharing memory. Okay, so setup's pretty easy. And then the next thing we should look at is, I guess, broadcast. So like I said, broadcast is run, it's actually executed by the test thread, and it's going to simulate being the commander. So it's going to send a message. So it's going to send the command to each lieutenant general. Now it will, let's just say it should tweak the command if it is disloyal. So that's part of the spec. I'll go back to it now. On page 2, a loyal commander will send the same command to each lieutenant general. A treacherous commander will broadcast R to the even-numbered lieutenant generals and A attack to the odd-numbered generals. There was not an example in those 4 test cases where the general was disloyal, but there could be in the marking test cases, so you should check that out and make sure that it works. It's fairly simple to code. So it does that, and then it should wait for the generals to finish. Oh, and just before I go any further, I'll just show you the code that you download. So there's a project, and inside there's really 3 main files. So there's final.c, which runs the test code. There's general.h, which just has the function prototypes, and it defines A and R for attack and retreat. And then there is general.c, which you're filling in. Here's general.c here. So you can see setup is basically empty, but there's the parameters for it. Cleanup, broadcast, and then general. And the code there is there for it to figure out what its ID is, but that's all that you're given. So that's what you're filling in, and that's what you'll be submitting. It's just that one file. Okay, so it waits for the generals to finish, and then it returns. So there's not much to be said for cleanup. Just delete any OS resources. So if you created message queues or created semaphores, you might want to delete them unless you're actually reusing the same ones for the other test cases. It's up to you. If you use malloc, I don't think you need to, but if you did, you'd want to free anything that you're not going to be using for the future test cases. Okay, and so finally the general function. And so the general function, what it's going to do is it's going to wait for the command. So for example 0:R. So probably you're going to have it wait on a message queue. That's the simplest way to do it. And then it will implement the OM algorithm. So I'll give you a rough outline for a recursive implementation of it. So what you could do here is you could invoke a helper function, let's call it OM, and pass it M, which is the number of disloyal generals, and it also indicates what level of recursion you're at, and the message that's been received, or the command. Okay, let's look at what the OM algorithm would look like then. So the OM algorithm has two cases. So if M is greater than 0, it's going to be calling itself again. If it's 0, then it's the last level, and if it's the reporter, it spits out the message it got. So if M is greater than 0, then what it wants to do is it wants to prepend its ID to the message. So in the case of general 1, it would stick a 1 colon on the front of it if you're using strings. And so you can use, I'll just give another tip here. So you can use a function called sprintf. So it's like printf, but it's for printing to a string. So the first parameter is the string that you want to print into, and then you give it the format string and then any parameters. So sprintf is useful for doing, manipulating messages. And then it will, it will send the message to the other lieutenant generals. And so if you recall, what I said before is you can look at the message that it's got to send out, and it will send it to any generals that aren't listed in that message. So it's not going to send it to General 0 in this example, or to General 1 in this example, but General 1 would send its message to Generals 2 and 3. Now, I should also say that it will modify, just thought of that, sorry, the message if it is disloyal. So if it's an even number general, it will always output, or it will always say that the message is to retreat, or the command is to retreat, and if it's disloyal and it's odd numbered, it will always say that the command is to attack. So you'd want to make that change first. And so send message to the other generals, you're just going to be doing os message queue put, and you're just going to go through the n generals, skipping the ones that are in the message name, or the list of who's gone through already. So once it's done that, then it's going to receive messages from the other lieutenant generals, and for each received message, let's call that RM for received message, it's going to invoke O. Now we're going down one level of recursion, so M-1, and then the message that is received. Okay, that's more or less it. It looks simple. The debugging's tricky, or can be. And one more tip before I move on here is here, if you're trying to figure out if a general that you want to send to is already in the message, there is a function. It's a string search function, but it's str, and you give it the string to search and what you want to find in it. So this for example, could be 10R. And remember, in your code, always when you're allocating space for your messages, allocate space for the null, the terminating null character. And then let's just say that you wanted to see if 2 was in the list. So you'd have to somehow create that string 2 : and see if it's in the list. So if you're using strings, if you're using structs, you're going to use some different technique. And else, and this will be the case where m is equal to 0, if the ID is equal to the reporter. So if this general is the reporter general, then you want to print out the message that's been received, and that's all you do. Otherwise, it actually just gets discarded. You just return, you don't do anything with it, since we're not calculating the majority values. So that's one approach. So I've shown you what corresponds most closely to the algorithm from the lecture notes. It is actually possible to implement the general function without using recursion with an iterative algorithm, where you just look at the messages coming in, prepend your ID and figure out who to send it to based on what's in the message. And you just got to make sure you have your message queues big enough. So that is it. I will have office hours for the next few weeks, and will be available for appointment help as well. Okay, hope it goes well.